A very warm welcome, my dear students. Today we are solving question 21 to question 30 from 06 to 5 October November 2025, paper 2-1. So let's quickly start with question 21. The diagram shows two beams of light P and Q passing through the same prism. Beams P and Q are both identical on the same point on the prism and at the same angle. Which row correctly compares beam P and Q? So we can see the beam P, when it hits the prism, it is splitting up. If there is splitting, then that means that there is some sort of dispersion that is taking place. If there is dispersion, that means there was white light involved, because only white light can undergo dispersion. So probably P was white light. On the other hand, if you look at Q, Q just undergoes refraction when it passes through the prism. So Q probably is a monochromatic source of light because it has a single frequency, since it does not undergo any sort of splitting or dispersion. So in option A, I have only Q is dispersed and P is monochromatic and Q is white light. You can see that Q is not dispersed. It is P which is dispersed. Therefore, P is white light and Q is monochromatic. Therefore, option D is the correct answer. Further, let us move on to question number 22. It says, the ultraviolet radiation and the infrared radiation are both parts of the electromagnetic spectrum. However, they differ in wavelength and frequency. Which row describes how they differ? See, you should learn the electromagnetic spectrum in the increasing order of their wavelength or the increasing order of their frequency. So, we know that we have UV light, then we have visible light, and then I have IR, which is the infrared. Now these I have written in the increasing order of their wavelength. If this is the increasing order of their wavelength, then this is also the decreasing order of their frequency. Now whichever side the wavelength increases, the frequency has to decrease. So now we can see which option matches as per our description. So over here it says ultraviolet has longer wavelength than IR, which is wrong. IR has the longer wavelength. So ultraviolet has shorter wavelength than IR. This would be correct. Infrared has a lower frequency than UV, which is correct. So infrared has lower frequency than ultraviolet. Therefore option D would be the correct answer. Let's talk about question 23 now. For question 23, it says, a police car with its siren sounding is stationary in heavy traffic. A pedestrian notices that although the loudness of this sound produced does not change, the pitch varies. Which row describes the amplitude and the frequency of sound? Now, for loudness, they told us that the loudness over here is not changing, or we can say that the loudness is constant. Now if the loudness is constant, we know that the loudness depends on the amplitude. Therefore, the amplitude should remain constant. On the other hand, they told us that the pitch varies. That means the pitch is changing. Pitch, on the other hand, depends on the frequency. So if the pitch is changing, that means that my frequency also has to change. Therefore, if I look at all the options now, I can simply say that the amplitude has to remain constant and the frequency can change. So amplitude constant and frequency varying, that is option B. Therefore, for this one, the answer is option B. Further, for question 24, it says, the diagram shows part of the magnetic field around two magnets. Which list gives the order of the magnetic field strength at the position P, Q, R from the weakest to the strongest? So if I look at P, Q and R, you can see that at R there are no magnetic field lines present. That means R is the weakest. Then if you compare Q and P, there are magnetic field lines passing through P and they are more crowded at P in comparison to Q. Therefore, Q is weaker in comparison to P. So P is the strongest. Therefore, option D is correct. The closer the magnetic field lines, stronger is the field. For question 25, a fully charged battery stores a charge of 18,000 coulombs. The battery is charged with a current of 830 milliamperes. How long does it take to fully charge a completely discharged battery? So we know that charge is current into time. This is the equation that we can use over here. So I have my charge given to me as 18,000 and I have my current given to me as 830 milliamperes. Milliamperes to amperes would be multiplication by 10 to the power minus 3 into time. So I can rearrange this. I would have 18,000 divided by 830 into 10 to the power minus 3. This will give me the time, but it will give me the time in seconds. When I put this on the calculator, I get 21,686.74 seconds. Now this is in seconds, but you can see in the options that all the answers are given in minutes and in hours. So first let's put it to minutes. So I divided by 60 and I approximately get this as 361.4 minutes. To put this in hours, I further divide by another 60 and approximately it comes out to be 6 hours. Therefore, the correct answer is option D. Now look at question 26. What is the definition of electromotive force? So electromotive force is basically the EMF. And who provides us the EMF? It is the battery that provides us the EMF. So the source over here of any sort of EMF is a battery or a cell. Now let's look at all the options in order to choose our correct answer. For option A, it says the electrical work done by a source in moving a unit charge around a complete circuit. This option seems to be correct. Let's look at the other options. The electrical work done by a unit charge passing through a component. This idea is wrong because EMF is the maximum that the work done, and maximum work done is always when you go through the complete circuit. It's the mechanical work done. It can never be the mechanical work done. So option C and D are out of question. The only correct option is option A here. Then moving on to question 27. A cell passes a current of 2 amperes in a circuit for 30 seconds. In this time, the cell transfers 120 joules of energy. What is the electromotive force of the cell? Electromotive force of the cell is nothing but the potential difference or the voltage of the cell. So we can use the energy equation. We know if we want to calculate the energy is given by the potential difference times current times the time for which you use it. So over here the energy is given to me as 120 joules. The potential difference is what we are trying to calculate. Current is 2 amperes and the time is 30 seconds. Now I can rearrange this equation for potential difference. So this would give me 120 divided by 60, that is going to give me 2 volts. So the correct answer here should be option C, which is 2 volts. Moving on to question 28. The diagram shows 2 resistors in series connected to a power supply. The reading on the voltmeter is 3 volts when the switch is closed. What is the value of the resistance R? See, if the reading here on the voltmeter is 3 volts, that means the reading across the 6 ohm resistor is 9 volts. Why? Because the total potential difference is 12 volts. This 12 splits up between the 6 ohm and the resistor R. So if R is getting 3 volts, then 6 is getting 9 volts. Now I can calculate the current through the 6 ohm resistor. So current for the 6 ohm resistor would be 9 divided by 6. This is simply by using the equation V is equal to IR. 9 divided by 6 will give me a current of 1.5 amperes. If 1.5 amperes of current passes through the 6 ohm resistor, then 1.5 amperes of current also passes through the R resistor, because these two are in series, and in series every component gets the same amount of current. Therefore, the value of resistance here would be equal to 3 divided by 1.5 amperes. That gives me a answer of 2 ohms. Therefore, the value of R is 2 ohms and option D is the correct answer. Let's talk about question number 29 now. Lamps can be connected in series or in parallel. That's true. What is an advantage of connecting the lamps in parallel rather than in series? Let's look at each of the options one by one. All of the lamps can be switched on and off using the same switch. No, that is what happens in series, but we are talking about parallel. Fewer connecting leads are needed to make this circuit. That is also not an advantage. When one lamp stops working, the others may continue to work. This is how the parallel circuits work, and this is a very big advantage. Therefore, option C is correct. Now, less power is transferred from the supply. This has nothing to do with the power. So, option D is also wrong. Only option C is the correct answer. Further, let us move on to question number 30. The lamps on a cycle are powered by a simple electrical generator. A permanent magnet rotates around a stationary coil of wire on an iron core. Which statement is correct? The current in the lamps decreases as the speed of rotation increases. See, this idea is wrong, because the current should increase if the speed of rotation increases, because the induced EMF increases. The current in the lamps decreases when the magnet is replaced by a stronger magnet. This is also wrong. When you have a stronger magnet, the magnetic strength increases, and hence the current in the lamp should increase, not decrease. The output electromotive force will be higher if the gap between the magnet and the coil is bigger. This idea is also wrong. Greater the distance, lesser would be the electromagnetic EMF, or the lesser would be the EMF induced. The output EMF will be higher if there are more number of turns. This is the correct statement, because greater the number of turns in the coil, greater would be the induced EMF, since there is greater interaction between the electric field and the number of turns in the coil. Great. So option D is the correct answer. So I hope you understood all these questions and my explanations behind it. If you like it, then please subscribe to my channel and also watch out for the next part of this video.